Hi, this video is a beginner's guide to generative AI, specifically LLMs, large language models. My name is David Hood. I'm CEO of 42 Robots AI, where we help organizations implement AI. I'm going to put some links to some relevant videos below that'll help expand on some of these concepts, and let's get into it. So really the objective here is to not just give you kind of like a hand-wavy type of overview beginner's guide, and also not to dig too deep into some of the technical aspects. I'll do like a little bit of a blend of some of the critical technical aspects, trying to explain them in very simple terms that are useful to actually being able to understand how to use these. That's really what this video is all about. So let's talk about some of the key terminology. So large language models, this is the most modern form of AI. This is the most recent thing that came out. This is what ChatGPT is and all of the rage. This is where all the money is going into, or most of the money is going into large language models. They are based upon a transformer technology that was built by Google. It was designed and created by Google in 2017. And actually the the technology is basically still the same as it was in 2017. The difference is data. Tokens, these are discrete chunks of little text. It's about 4 characters, but the tokens can be smaller or larger than that. There's training. Then there's various types of training. There's pre-training and fine-tuning, let's actually open this up. Yeah, so pre-training and fine-tuning, and this is how you kind of guide a model. The pre-training is the most expensive part. This is what costs, to make GPT-4 like $1 billion. We don't know the exact number, but it's something like that. And this is the expensive part. This is the part that takes all the resources as it combs through the data, and it kind of cycles back and forth. That it says, okay, what do we expect the next token to be, and then what does it end up being, and then it uses that back and forth, and it does a bunch of different stuff. You don't really need to know, and I don't think I know all of the details of exactly how pre-training work. It's a little bit complicated, but you don't need to know that. Just know that that's the expensive part. That's where they consume all the data. Then there's fine-tuning, which kind of narrows the band of results and also allows you to control the form of the outputs and the outputs themselves. And then you have the prompt. This is the input to the model. And this is, so like if I'm going to ChatGPT, the thing I put in, that's the prompt. There's prompt engineering, which is essentially engineering the input to the model to get the output that you want. I think this is not really well understood in general, not just how to do it, but what it really is. Most people think of this in terms of prompt engineering for the chatbot, but there's a whole other type of prompt engineering that I think is more important, which is using it within software. There's RAG, retrieval augmented generation, which essentially goes and grabs some context from somewhere else and puts it into the context window, which is essentially the prompt. For context to help answer questions. GPUs, these are essentially, they're not CPUs, but they're GPUs. This is the main hardware that runs the models. Both, I guess you have inference. Inference is when you're actually running the model, but also the pre-training part and the fine-tuning. All of this is run on GPUs. These are very expensive, cutting-edge things made by NVIDIA. Okay, a lot of confusion around this. ChatGPT versus GPTX, for GPT-4, for example, and OpenAI. A lot of times people call the model ChatGPT, or they call the company ChatGPT. ChatGPT is the interface that you use to access their models, which is the GPTX, and then OpenAI is the company that makes those. Open source, I have open in quotes because there's kind of a new definition that needs to happen for open source, because there's multiple aspects of being open. Even Llama 3 by Meta is not fully open source. There's open weights. There's just kind of open where you can use it and fine tune it for yourself. And so it's not fully open, but it is more open source than, say, OpenAI's, ironically, models that are completely closed source. There's multimodal, so these are models that use not just text, but also potentially images and audio, or maybe video. Right now, GPT-4o is multimodal, and Claude is as well. So let's get into a little bit of the basics of how LLMs work. So again, I think I already kind of covered training and pre-training, but when you're doing inference, it's essentially predicting the next token. So you give it the prompt, and then one token at a time, it predicts and there's randomness in terms of how it predicts the token. So it'll say these 10 tokens represent, this one is 50%, this one's 30%, this is 20% or whatever. It's not that simple, but basically they'll go, okay, and then it'll randomly pick one of those tokens. And so that way it doesn't always generate the same outputs from the same inputs. But also one of the downsides of this is this is part of why you get hallucinations. It's actually crawling its data set to go grab the most relevant information, and sometimes it grabs the wrong things, or sometimes it grabs something unlikely and it kind of goes off the rails. Ironically, they're not good at math because they are language models. People are trying to build this in, but typically they're using like some sort of bolt-on, oh, this is math, okay, we're going to go over here and use this other tool. Some people think of these as regurgitation engines, and they're not completely wrong. I think they can create new things, but I would say that more likely they're able to create new recipes and not new ingredients. And so this is why you can recombine different things, but it's probably not going to discover, at least in the current technology, new laws of physics that there's no framework for that we have already. So that they are in a sense regurgitation engines, but they can do more than that. It's extremely expensive, as I pointed out, to train them, and even the ability to run them. So a lot of the investments into these companies are being given by the bigger companies like Microsoft and Google and Amazon. The investments are coming in the terms of GPU credits. So they're able to artificially, it's kind of almost free, give away the usage of it to try to get market share. And so there's a chance that the costs might actually go up over time when the giving away of these free credits goes away. Speed is pretty important. They are generally slow. They've worked on making them a lot faster, and there's a lot of work to be done on this because this has a huge effect on building these into products. But I do think they'll get to the speed pretty soon, especially as the models get better and better, and you can have lighter weight models that do more. There are very serious limitations, especially when you think about how next token prediction works. There's a whole bunch of stuff that they can't do. This is not a full intelligence. This is not a mimicry of a brain. It is a mimicry of a slice of one part of the brain without lots of the other pieces to the systems. And so there's a lot of stuff that it cannot do or does not do very well. Back to the point, the paper, the Transformer technology came out in 2017. And this is basically, the Transformer is still the same 500 lines of code almost that it was in 2017. The top model in 2023 that came out, that was probably to me ushering in the modern era of LLMs, is GPT-4. The models really haven't changed that much since then. That's a year and a half ago, and they basically have plateaued as far as I can tell. And I don't expect GPT-5 to be orders of magnitude better. I expect it to be linearly better and cost exponentially more. So let's distinguish between let's talk about how to effectively use LLMs. Most people are thinking about this in terms of chatbots, how to use ChatGPT, blah, 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 versus calling it with an API. This is much more important, in my opinion, and opens up a lot of possibilities. Highly recommend you study my video on new capabilities, because there's a lot of new cool stuff that we can do with LLMs. Now, while there's a lot of limitations and there's a lot of hand waving on their amazingness and them being entities, there are new things that we can do now that we couldn't do just a couple years ago. One of the things they're really good at is brainstorming. This is even with a chatbot, this is one of the best things to do with a chatbot, is to use it for brainstorming or kind of like seeding your starting work set. It's really good at that. Doing a deep dive on prompt engineering is beyond the scope of this video, but I'll give you a real quick my guidance on this. First of all, you want to create sections within there. If your prompt is simple, you can just do simple. It doesn't matter too much. But if you have a long prompt, which sometimes is really useful, then you want to do all caps sections. The first one you want to do objective, and the last one you want to do instructions. And sometimes these can be almost exactly the same thing, if not exactly the same thing. And then in the middle, you want to tell it, here's some context, here's some formatting, here's some details about different stuff. Again, have different sections, and use the all caps within a different section to refer to another section. This is very useful. And I do recommend, testing, but this, I don't know if you need, at least in our experience, we don't need like super fancy tools for testing. It doesn't require a lot of prompt engineering. You don't require 100, 1,000 iterations to kind of get a good idea of whether or not the prompt is doing what you want. Usually you can do it with a human, with 3 to 10 different outputs. RAG is very useful, but I don't think really well understood in terms of what you can really do with it. There's a lot of really cool stuff you can do with it beyond the simple versions of RAG that I see out there. But recommend playing with a vector database and testing how to do that, and using that to inject relevant materials based upon the input. But very, very, very useful. Reliability, this is part of the reason why you want to use the APIs, because if you're just using chatbot, like a very general model, the outputs are not going to be nearly as reliable as you try to push as much of the solution into the model, into one prompt, into one action, versus when you use it with an API and software, you pick apart the problem and you pull out of as much of the solution from the problem as you can, and that gives you much more reliable outputs. And then you want to, and part of pulling out is it allows you to parse inputs and outputs so that you can pick apart the problem even better. And this dramatically increases the reliability of the outputs, which dramatically improves your ability to effectively use LLMs, especially within like an enterprise organization. If your answer to using AI is, I'm going to get Microsoft Copilot, you're going to be stuck with this chatbot, and you're going to be extremely limited in your ability to provide high quality, reliable outputs. Each one of these could be their own videos in and of themselves. If you want me to shoot a video on any one of these specifically, please put a comment below. Please like this video and subscribe for more like it. And if you'd like a free custom AI implementation roadmap for your company, give us a call or click the link below, and we'll go from there. Thanks, and have a great day. Bye.